Hey everybody, this was a quiz on basic polynomial functions. When I say basic, I mean introductory as we discuss the vocabulary of polynomials. For example, how to know if something is a polynomial in the first place. So in this video we're going to discuss that as well as the characteristics of a polynomial, like the degree, leading coefficient, writing it in standard form, things like that. How to name a polynomial function. Is it a cubic binomial? Is it a quadratic trinomial? That type of thing. And then we'll move on to the binomial theorem and Pascal's triangle to expand some binomials. Alright, we'll see how far we get in this video. Alright, so are these polynomials? Well, a polynomial is going to be a term or sum of terms that meet two main criteria. The first one is the exponents have to all be whole numbers. So as I look at these exponents, I see 2, 5, and this is a power of 1. Those are all whole numbers. There are no negatives or fractions or anything like that. So far, so good. The other main characteristic is all of the coefficients have to be real. So please understand the coefficients 5, -2, 17, those are all even integers. So they're definitely real. But even things like pi and square root of 5, these would also be real. So when we're talking about something that's not real, we're talking about complex numbers, imaginary numbers. So if we had a coefficient that had I in it somewhere, then that would not be a polynomial. But under these two main characteristics, this is definitely a polynomial. So we will say yes. Looking at B, is this a polynomial? Well, yes. Again, this is a polynomial. It still meets the criteria. Alright, the exponents are all whole numbers. This is a 1, that's a 2, this would be a 0 power. The exponents are all whole numbers. Then the coefficients are real. For example, look at this term right here, x over 2. You could look at that as 1/2 x. And because you know how there's that invisible 1 in front of everything. And same thing here with this. This is like having 1x squared. So you could write this as 1/2 x squared plus 13. So the coefficients are fractions, 1/2, -1/2. But fractions are still real numbers. They're rational. So that's still a yes. Now for C, this is going to be not a polynomial function. And the problem is, you see these variables in the denominator? Well, this would be the same thing as having 7x to the -2 power. Okay, because we know that, for example, x to the -2 power is the same thing as 1 over x squared. So when you see a variable in the denominator, it would be the same thing as bringing it up to the numerator and having a negative power. So in the same way, this second term is the same thing as 13x to the -3 power. So -2, -3, these are not whole numbers. Whole numbers do not include the negative numbers. Okay, so we could say no because the exponents are not all whole numbers. Just it fails that first test right there. Okay, look at D here. What about this one? Well, this is going to be no for the same reason. Okay, last year you should have learned that radicals, square root, cube root, things like that, are the same thing as fractional exponents. For example, cube root of x is the same thing as x to the 1/3 power. Okay, and so we have a coefficient of 12, but this is the square root of x. Square root is the same thing as 1/2 power. So again, these exponents are not whole numbers, so that's why this is not a polynomial. All right, and this one down here is back to being a yes again. All right, because once again, all of the exponents are whole numbers, and the coefficients are all real, so we have no problems there. Okay, so that's how you tell if something is a polynomial in the first place. Now, here's a polynomial right here. Notice that that coefficient is not a problem, so it is a polynomial. Now let's talk about the degree, the leading coefficient, and let's write it in standard form. Now, as far as the degree is going to be the highest exponent in the polynomial. So we see that the highest exponent here is 3. So that tells us that the degree is going to be 3. Now, the leading coefficient. The leading coefficient is going to be the coefficient of the term that we got the degree from. So if you look and you see, okay, we've got the, let me zoom in a little bit. Okay, that highest power was the third power. So that means this term is going to be the term of the leading coefficient. So even though it's not in the front right now because it's not in standard form, the -2 is still the leading coefficient no matter what. So the leading coefficient is -2. And when we put it in standard form, the leading coefficient will be in front. So I hope no one's putting 3/2 as the leading coefficient. Most students find it easier to go ahead and write the equation in standard form first, and then the leading coefficient is obvious. So as far as standard form, which is what we're going to do right now, we have to put all the terms in order so that the highest exponent is first, and then it decreases from there. So we have exponents 3, 2, this is like x to the 1 power, and this term is like having x to the 0 power. So we're going to rewrite it so that it's first we should have -2x to the 3rd power, that's the highest, and then we should have our x squared second, and then we should have our 3/2 x to the 1 power. I'm not going to put the 1, but 3, 2, 1. And then this constant of 7 is the same thing as 7x to the 0 power. I'm not going to write the x to the 0 power. But now it's in standard form. Exponents 3, 2, 1, 0. So we'll go ahead and put that right on the line. Alright, so next we're supposed to classify the following polynomials by degree and by the number of terms. Okay, so we're going to come up with names like cubic binomial or quadratic monomial, that type of thing. Alright, so let's just review the system real quick. Let me get to another page. Whoa. Okay, let's just review how it all works. Okay, so we're going to be classifying by the degree and the number of terms. So first of all, degree. If the degree is degree 0, then that's going to be a constant. Okay, so that's just you know, that's just would be a number. If we have degree 1, that's going to be linear, is the word we will use. If we have degree 2, oh, by the way, linear, that would be like 7x would be linear. If we have degree 2, that's called quadratic. Okay, so that's, like 7x squared plus 3x. That would be quadratic. If we have degree 3, we call that cubic. Okay, so if this was 7x to the third power, now it's cubic. And if we have degree 4, we call that quartic. So don't get confused between quadratic and quartic. Normally when students see the prefix quad, they naturally think 4. But in this case, quadratic is degree 2. It's something squared. Alright, if you want degree 4, fourth power, you need to use the word quartic. Okay, and I'll go up one more level. If you ever see degree 5, that's called quintic. Alright, that's as far as we're going to go in this class. On the other hand, we can classify according to the number of terms. Number of terms. Okay? If there's one term, we call that a monomial. Okay? So if I just have 7x to the third power, that's a monomial. If there are two terms, we call that a binomial. Okay, so if I had 7x to the third power plus 5x, that's a binomial. If I have three terms, that is called a trinomial. Okay, so if I have 7x to the third power plus 5x minus 2, that is a trinomial. Okay, now anything 4 terms or over, we don't have a special name for the number of terms. All of these are polynomials. A monomial is a special kind of polynomial. A binomial is a polynomial. A trinomial, these are all special polynomials. But when we get beyond 3, polynomial just has to be good enough. So 4 plus terms, or maybe I should say it more like if we have 4 terms, 5 terms, 6 terms, etc., we just go with polynomial. Okay, they're all polynomials, but we just give up on the special names after 3 terms. Okay, so that's a review of the naming system. So, oh, by the way, so we put those together. So take this one right here, for example. By degree, this is cubic because it has degree 3. By number of terms, it is a binomial because it has 2 terms. So we would call this a cubic binomial. So that's kind of how it works. So with that in mind, let's get back to the problems on this particular assignment. So for number 6, it is squared. So that makes this quadratic. Okay, so we will call this quadratic. And it has 3 terms, so it is a trinomial. Alright, quadratic trinomial. Alright, watch out for number 7. It's important that you notice that this polynomial has not been simplified yet. Okay, unlike number 6, which was already simplified for you, you need to simplify the polynomial before you try to name it. So the only thing that needs to be done here is these like terms need to be combined. If you do that, then you've got 6x to the third power plus 11x minus 8. Now you can see that instead of the 4 terms that it really it at first looked like it had, it's really only 3 terms. So first we'll name it according to the degree. Since the degree is 3, we will call it cubic. And since there are 3 terms, it is a trinomial. Okay, so this is a cubic trinomial. So I'm going to stop this video here with that basic terminology of polynomials. We'll pick up on the next video using Pascal's triangle to expand some binomials. I'll see you on the next video.